Okay, guys, welcome to our class for today. This is Nobleman Science Tutors Online, and today we are going to be looking at frictional force that is required to, or the force that is required to pull an object up an inclined plane. Remember that in our previous classes we've discussed frictional force up to frictional force down an inclined plane. So today in our class we're going to be looking at the force that is required to pull an object up a plane, up an inclined plane. So this is Normal Science Tutors Online. I remain notable Michael. Please, if you have not subscribed to this channel, click on the subscribe button and also click on the notification bell so that when we upload a new video, you will be notified. Also, if you have any comment, you can put them on the comment section down below. And please give us a like, give us a thumbs up, and invite your friends to come and join this wonderful channel. Also, you can reach us via the WhatsApp number that is showing right on your screen. So for us to go to our class, please get your writing materials and get settled so that we can go to our class for today. Actually, we are going to solve problems. There's not too much discussions because we have done all the normal discussions on friction. So what is left now is just for us to solve problems depicting how you can calculate the force that is required to pull an object up an inclined plane. So right away, let's go to our class for today and solve some problems to analyze how to find the force required to pull an object up an inclined plane. So we are going to our class right away. So we are looking at the force that is required to pull an object up an inclined plane, right? So for an object to move up an inclined plane, the force or the pulling force must overcome 1. The frictional force, and 2. The weight of the object that is parallel to the plane. So the component of the weight of the object parallel to the plane, the force must overcome that, and it must also overcome the frictional force that is also acting downward opposite to the pulling force. So you have a diagram that looks like this. Okay, fine. So you have a diagram that looks like this. The P is the pulling force. Then the force that this P must overcome is the component of the weight down the plane, and then the frictional force that is acting opposite to this pulling force. Don't forget that this component has already been resolved. So this is a component of the weight down the plane, and then this is the component of the weight that is perpendicular to the plane. Okay, so these are the equations that we derived before. The weight parallel to the plane is W sine theta, and then the component of the weight that is perpendicular to the plane is W cos theta, and this is equals to the normal reaction. So therefore the pulling force is equals to the parallel component of the weight, which is W sine theta, plus the limiting frictional force, which is F mu r. That okay? So when you write the equation, this is the equation that you're going to have, and then you can now combine them, substitute for r, substitute for F, for you to have P pulling force equals to W sine theta plus mu r, which is frictional force, and we know that r is equals to W cos theta, and that is what is substituted here to have this equation. Don't forget that for an inclined plane, the coefficient of friction is either equals to tan theta, the tangent of the angle of the inclination, or you can get it from the values or the equations for the force parallel to the plane and the force perpendicular to the plane, which is W sine theta all over W cos theta. So please guys, take note of these equations that we have derived here, because we are going to use them now to solve some problems. Is that okay? We're going to use them to solve a problem, to drive home how to solve this problem that has to do with pulling an object up an inclined plane, right? Okay, so This is a question that we need to look at. An object of mass 15 kg is at the point of sliding down a plane inclined at 36 degrees to the horizontal. Find the least force parallel to the plane required to make the object to begin to move up the plane. So this question depicts what we just discussed now. Is that okay? So you can actually draw the complete diagram. I just drew this one. So you can draw the complete diagram. So here you have your frictional force that is acting opposite to the plane. That's okay. So you can complete the drawing yourself. Okay, so this is the frictional force. Then this is the component of the weight. The component of the weight down the plane. Right? This is component of the weight down the plane. Then this is the pulling force. The force that is pulling the object up the plane. And this is what we are looking for. So then the component of the weight that is perpendicular to the plane, W, that is W cos theta. Okay, so these are what we already know from our previous discussion. So for this particular problem, we are giving the angle of inclination to be 36 degrees. 36 degrees, that is the angle of inclination that has been given to you, and the weight is 15 kg. Alright, so G is given to you. So here we have theta to be equal to, theta is 36 degrees. Okay, that's what is given. We also have that the mass of the object is given to you to be 15 kg. That is given to you to be 15 kg, right? Then you have G is given to you to be 10 meters per second squared. Alright, so if we use the equation that we got before, that we derived before, that P, using this equation, P is equals to the force parallel to the plane, which is equals to W sine theta plus F, which is the limiting frictional force that is down the plane, right? So this one you can also write it as, substitute for F, W sine theta plus mu arrow. Okay, don't forget that arrow is equals to W cos theta. Okay, so arrow is equals to W cos theta. Now, before you can solve this problem, you must first of all find this coefficient of friction, right? So coefficient of friction, from our previous equation, we said that coefficient of friction mu equals to what? W sine theta all over W cos theta. That is your mu. That is the coefficient of friction. So just substitute the values into this equation. If you substitute your values into this equation, you are going to have that W is mg, which is mass times acceleration due to gravity. So that gives you 150. 15 times 10 is 150 times sine 36 degree. Sine 36 degree. That gives you, if you check that from your table or your calculator, you have 0.5 89 divided by 150 times the cosine of 36 degrees 0.809. Okay, so if you work that out, you are going to have that this will give you 88.2 all over 121.35. Okay, by the time you do that division, you will now have that the coefficient of friction is equal to 0.73. That's what you will have, 0.73. So this is your coefficient of friction. You need this one. You need this coefficient of friction to solve for this particular pulling force. Is that okay? So your coefficient of friction is 0.73. Let me write it clearly. So this is 0.73. That okay? So this is your coefficient of friction. So haven't gotten this, you can now substitute all your values into this particular equation. W sin theta is already here. You already have it here. Coefficient of friction is here. Normal reaction, which is W cos theta, you already have it here. So just substitute your value into this equation, then you get the pulling force. So if we do that, we're going to have this. W sin theta is 88.2 plus 0.73 multiplied by W cos theta R, which is 121.35. Okay, so when you work that out, you're still going to have 88.2 plus what? Plus 98. You multiply that out 98.59. So when you do that addition, if you do that addition, you have you're going to have so this is 88. So let me clean it so that I can write it clearly, please. Okay, so this is 88.59. So when you add this together, you are going to have 176.79 or 7918. Okay, so this gives you the force that is required to pull this object up. So this force is equals to the limiting frictional force that is acting opposite to the force, and then the force, the component of the width that is parallel to the plane. Don't forget that this coefficient of friction, you can also find it using tan theta. Tan theta is the same thing. When you find the tangent of theta, the tangent of 36, you also have this 0.73. So it's either you use this formula to find your coefficient of friction, or you can use tan theta, the tangent of the angle of inclination. It will still give you the same value that you have here. Then once you have gotten that, you can so just take note of how this problem is solved, right? For you to have the force that is pulling this object up the inclined plane. So thanks guys, this is how to go about this problem. In case you have come across any question like this, I will encourage you to solve more problems from your textbooks, solve more problems from frictional force from your textbooks. Is that okay? All right, so we are going to your test page. Okay, fine. So this is your test your understanding page. A body of mass 10 kg rests on a rough inclined plane whose angle of tilt theta is variable. Theta is gradually increased until the body starts to slide down the plane at 30 degrees. The coefficient of limiting friction between the body and the plane is what? So this is actually a jam question and I want you to attempt it. Please paste your answer on the WhatsApp page, right? Just state the question and then paste your answer on the WhatsApp page, the WhatsApp number that is showing on your screen, that will be displayed on your screen. You can actually solve it on a paper, snap it and send it across. I will look at it and then make my comment. If your method of solving is okay, then I will also make my comment and then guide you on how to solve further other problems. If you have any challenge in physics, you can always reach me through the WhatsApp number that will be showing on your screen. So guys, thank you so much for your time. It's been a wonderful time, wonderful learning experience. So please continue to visit our channel. Invite your friends to also come and visit this channel so that they can enjoy the lecture that you are enjoying. Give us a thumbs up. Please click on the subscribe button. Also click on the notification button so that whenever we upload a new video, YouTube will notify you. This is Nobleman Science Tutors Online. We are bringing physics class to your very doorstep. You can reach us via the WhatsApp number that is showing right on your screen. So thank you so much for your time guys. I'll see you in our next class.